Good afternoon, sir.
Yeah, good afternoon, sir.
Okay. So, good afternoon on one and all. Now, I request good afternoon, one and all. I heartily welcome to the Atal Online 6 Days FTP program. Session 11. Today's resource person, Dr. M M Irfan, sir, head of the Department of SR University, Triple E Department. Now, I request Anusha, madam, please introduce today's resource person, Dr. M M Irfan, sir. Thank you, sir.
Good afternoon, everyone. My name is Anusha, Assistant Professor in Triple E Department. It's my honor and privilege to introduce Dr. M M Irfan, sir. Dr. M M Irfan, sir, did his PhD at JNTU, Hyderabad. Currently, sir is the head of Electrical and Electronics Engineering Department at SR University, Warangal. Sir is working as the editorial board member, Scientific Report Q1 Nature Journal, and Sar is guest editor of PLOS One Scientific Research Q1 Journal and academic editor of Jordan Journal of Applied Sciences. Sar areas of research are electric vehicles, wireless charging, hydrogen fuel cells, power converters, so on. Sar published more than 35 articles in the quality journals and prestigious conferences. Sar delivered talks on emerging technologies like EV, hydrogen fuel cell, Industry 5.0, renewable energy, and AI applications. In addition to that, Sar is an expert in social innovations and design thinking. Sar received patent grants and also transferred technologies to the industries and NGOs. Sar acted as a teacher along with Professor William Oakes, USA, for the design thinking course conducted by IUCEE in the year of 2018 and 2019. Sar received the National Level Leadership Award for Project-Based Learning by IUCEE in the year 2020. Now, Sar is supervising 3 full-time and 5 part-time research scholars. Thank you. Thank you, sir, for giving this opportunity. Welcome, sir.
Thank you, madam. So now I hand over this session to Dr. M M Irfan, sir. Please continue this session, sir.
Yeah, thank you very much. Is it visible, sir?
Yes, sir.
Shall I start?
Okay, sir.
The slides are changing, sir.
Yes, sir. Changes. Okay.
Very good afternoon. Today's topic of discussion is explainable AI for renewable energy sources. We already aware about the artificial intelligence. What is this explainable AI? What it actually reflects about, and how it is going to be different from normal AI, and how it is going to give the advantages in different sectors, especially renewable energy sector. Today we are going to discuss about. Let me go with basic things first. AI refers to the branch of computer science that focuses on machines or software that can perform the task that would normally require the human intelligence, like reasoning, problem solving, and learning from the experience, and then clustering, grouping, and natural language processing. Even the decision making and recognizing or predicting the things is the basic characteristic feature of AI. In simpler terms, AI involves the building systems that can mimic the cognitive functions such as thinking, understanding, and learning. This is normal AI, what already we are aware about. Then why this XAI comes into picture? What is this explainable AI? Explainable AI is represented with XAI. X, the letter X represent explainable. So this topology of new version of AI is becoming more popular and predominating in the different sectors of the industry. Explainable AI. Let me go behind what is the necessity of this XAI. Explainable, from the name itself, you can understand. In the previous AI models, we used to have a black box approach where some inputs we are giving and we are getting some outputs. We don't know as a user, and most of the times as a data scientist also, what really happening inside that black box. So because of which this AI is not occupying the respect and the trust in many of the industry sectors, especially the sectors which are very sensitive in nature, like your electricity is there, electrical engineering, like your medical field is there. These are very sensitive fields where the things, if they are mismanaged, if they are misinterpreted, misdiagnosed, and the outputs what we are getting out of these models are not desired one, then obviously the system is going to collapse. A huge risk are the damage we have to bear because of such practices. So AI is not occupying the amount of trust among these domains where the sensitive nature of applications are available. In the medical also, for different model, for different example, if you're giving different patterns of your x-ray or your MRI scan pictures, okay, and if you want to diagnose what is the level of cancer available in the patient, if these models are the pictures whatever we are capturing and giving to the model, they are not appropriately learning themselves and giving accurate results, that might create a problem for the patient, and it's a life risk issue for the patient, and it's a problem of reputation. Similarly, in electrical engineering also, where many of the renewable energy sources which are coming into picture, they are very uncertain in nature. Like wind, it all depends upon the velocity. Solar, it all depend upon the irradiance and temperature. So to handle such type of uncertainties and make the model more effective, precise and accurate is not possible with the available black box model of AI. In the black box model of AI, the user don't know what is the logic behind the prediction, why the output whatever the AI model is giving, the user can't understand, because the model won't justify. Just it's a black box model. What's happening inside, nobody knows. And finally, you are getting some output. That output the user has to use, and you have to take the decision. So, the normal conventional AI approach is missing with the explanation of the things happening inside the module, inside the black box. So, this white box approach came into picture, where the decision making process has to be known to the user also, how the model is trained, and it is giving a specific decision. Those logic and the rules also should be in explainable format for the user to understand. This is the basic necessity or the nature of the XAI. Here I have pointed out 4 points. You can see, why does the AI is taking a specific decision? How does the model look like? What assumptions the model has taken? Under which conditions does it perform badly? So these are the very important things, because of which the users don't have enough amount of trust on the AI model. So this XAI is coming up with new features like transparency, interpretability, and explainability. These are the three important features of XAI, where the model is will be very transparent in nature. Means it's a white box model. It will be giving a clarification or the justification for the user to understand what actually the algorithm is doing, what actually the AI model is doing. So the interpretation should have enough sound justification. That justification with taken assumptions should be known. Those logic should be known to the user through explainability format. That is why this XAI is coming into picture, and it is occupying the AI, especially in the very sensitive domains like medical field and electrical engineering field. A small reference also I have quoted in the slide. You can see the book Interpretable Machine Learning, a guide for making the black box models explainable. This is Christoph Miner, the writer of the book, has clearly mentioned about the reasons behind the conversion of black box model into white box model, and what are the different techniques or the strategies we need to adopt to provide the justification for each of the algorithm in a user understanding language. This book is very important. If anybody is really interested to go ahead in this domain for the research, you can have this handbook as a manual for your research work. Yeah, as I said, the definition. The narrow definition of AI, techniques and methods that makes the model decisions understandable by the people. But the broader perspective, everything that makes AI understandable is called as explainable AI, including the data, the activation functions, the architecture or the configuration of the model, the layer network, the performance and the behavior, the training and the learning algorithms, all these are very important while we are going to take this XAI into the picture. So, in a broader perspective, we can say that this is more intelligent, this is more comprehensive, this is more strategic in terms of making the people or a common man understand what actually happens in AI. Till now, everybody knows that AI is doing amazing wonders, but as a layman, nobody knows how it is doing these wonders. Only the data scientists are the experts of the machine learning. These machine learning engineers and data scientists also very uh, in a precise, they can't give the precise justification, but overview they can give how the things are happening. So this technical stuff or the logic or the reasoning behind the things happening in the black box to be explained to the user in a user centric language, and this happens through this XAI. XAI is not just a machine learning model, but we are going to explain the every supervised machine learning model also in terms of XAI. In next coming slides, I will explain about the supervised learning strategies of XAI. Yes, this is how the process happens in AI and XAI. In AI, what happens? The data, whatever you are giving to train the model, that data is given to the model, and then through some learning algorithms, the machine will train for the given data, and then it will take concise, specific decisions through some learned functions. And these decisions will be displayed for the user to go ahead forward. But user will be having a question always in his mind. Why did you do that? Why did you do that? Why did you do that? Because the we are much not aware about how the things are happening. Everywhere you will be having a question mark. Coming to XAI picture, we are coming up with a new machine learning model. We are giving the data to the new algorithm models, because explainable model should be a mediator between the user language and the machine language. Because the new algorithm, whatever the decisions it is taking, depending upon the set of rules, those decisions along with the logic and the rules, they have to be displayed to the user, but not in machine language but user language. So there will be one explanation interface through which the user will be understanding what exactly model will be. The user will be happy, and he will be having a great trust, and he will be understanding the accuracy, the precision of the output. The user will be telling, I understand now. Why? I understand why not. I know when I will succeed. I know when I will fail. I know when to trust, and I know how to correct the error. So this is the difference between the AI and XAI. which makes XAI more predominant, more trustworthy, and because it's giving enough justification, it is also coming up with different precision and accuracy based models where it is continuously making itself trustworthy, because of which the output also, the response of the model also is becoming very perfect and accurate. Yes. What is the need of explainability? As I already mentioned you, to improve, to control, to build trust, and to discover the error. These are the four important objectives why this explainability AI came into picture. First thing is human readable justification of the decision. Most of the decisions which are being made by the users, naturally, they don't go through the logic what they have followed, such that human can also understand the reason behind the decision. So this is one of the major objective of the explainability necessity. The second one is compliance to legislation. When everyone behind their decisions, so this legal right to understand their decisions or others decision through proper justification is very important. Then only we can control the data, then only it's possible for the user to trust and use the data. Third one is to improve. So before going to improve, first of all, we should know what sort of errors are there, flaws are there. Okay, what are the shortfalls we are having through which we can improve using this XAI, and then finally to discover the output. It should be for extracting the information required by the user of a specific domain. Yeah, these are the three important things with simple examples also I have taken here. Improving the models, enhancing the control, and then discovering the knowledge. These are the three reasons which are very important why people are going towards explainability. A simple agricultural example I have taken, the diseases caused to the plant after diagnosis they will be treated, and so in normal AI, if you are using these models, won't give enough justification to the decisions. Simply, if you are giving 1,000 or 10,000 pictures of different stages of the disease of any specific plant, and these inputs you are giving to the black box, and black box is giving that this plant is having this disease or something else, but specifically it is not giving proper justification for the user to trust the output. So here the control will be enhanced through XAI, where reader or the user will be understanding the enough justification, and through which the knowledge can be extracted and it can be used for further treatment or for the further improvement. These are the three core elements of XAI. As I said, transparency, interpretability, and explainability. Transparency, access to different ingredients, and interpretability, presentation of properties or features of the machine learning model in understandable language to the user. Explainability, it is a combination of interpretable entities with the domain knowledge. All this explanation depends upon case to case. It varies with case to case. It is not specific type of model for every application. It all depends or varies from case to case with respect to these three core elements of transparency, interpretability, and explainability. Yeah, one more important concept comes into picture here is causation and correlation. We all well aware about the cause and effect principle, the law of cause and effect. That means an output is the result of the occurrence of any specific input. That is called as cause and effect relationship, causation. Whereas correlation is something different. It is the relation between the input and output. It is not like causation. Causation and correlation are two different concepts we need to understand. Once we understand these two concepts very clearly, it will be easy for us to develop the XAI models. Causation is something which is uh, because of specific input you are getting output. Means output is a function of input. It is called as causation, cause and effect. Whereas correlation, it is the relationship, just a relationship between the input and output, does not necessarily, it depends upon the input function. Causation may not happen, only correlation may be possible. Like here is simple example I have shown here. There is a relation between rain and umbrella, and there is a cause and effect concept between the rain and the plant. You can see here, whenever it is raining, the plant will becoming very healthy, very productive. The agricultural farming lands will give high amount of yielding. So there is a cause and effect here. Because the input is rain, you are seeing the effect that the trees or the plants are getting developed themselves, becoming more productive and yield oriented. This is called as cause and effect relationship. Whereas another side, it is not cause and effect, it is the just correlation between the rain and umbrella. Umbrella we are using because it is raining. Okay, this is the relationship between input and output. Never this is happen that there is a relation between umbrella and plant. No, never. So this causation and correlation should be explicitly understandable or explainable in format for the user while we are taking the decisions. Yes, coming up to the types of XAI, we can also call as uh, characterization of XAI. How we are classifying the XAI. This classification is possible in four different varieties. One is agnosticity, second one is scope, third one is data type, and fourth one is explanation type. Let us take one by one. Agnosticity. It is having two types, model agnostic and model specific. Agnostic means it is applicable for every type of model. It is not designed or developed for a specific domain, specific application, or specific cause and effect relationship. So it is called as model agnostic. If your model is domain specific or learning model specific or application specific, then we can call it as model specific. Similarly, scope. We are having two possibilities. One is global and one is local. So the models which are explainable for the whole model, it is called as global type of model. The scope is having a high global perspective, whereas local individual predictions, case to case, model to model, input to input, it all varies. Okay, if the non-linearities are available in the model, those non-linearities we need to check individually, not as a whole, not as a whole system. In the system, there are variety of components. For example, you are taking a solar plant, you are taking a wind plant, wind energy conversion system. There are variety of components, solar panels, and then MPPT controllers, and then your power electronic converters, and then your grid connected inverters. So variety of components will be there, and each of the component will be having its own learning capability. considering individual predictions. If you are preparing the XAI model, it is called as local XAI. Third type is data type. Based upon data, we can classify or divide the XAI modules or the system, like a graphical representation or image oriented, tabular representation, just simply the text and speech you are using. So, which type of data you are giving as the input set for the training to the new model. So depending upon the data also, your model of XAI will change. So we have to be specific in terms of the type of input while you are going to develop the XAI model. And then the fourth one is explanation type, justification type. Which type of user centric or user understandable approach you will follow. There are a variety of human-centric display boards are the interface through which the output can be made justifiable for the users, like visual or with respect to data points or with respect to surrogate and feature importance. So, what type of explanation you want to take or consider while you are giving the justification or the logic behind the model to the user. So with respect to that also, your AI model or the XAI model will change. These are the four types of XAI models available. That is, we can call it as characterization of XAI. So here we all know about the process: data understanding, data preparation, modeling, evaluation, deployment. All these are the different phases of any AI cycle. In this AI cycle, everywhere the human involvement is necessary. For example, you are giving data. So is the available data sufficient, suitable for the specific project or the defined targets or the goals? Then the human involvement is required. You have to check whether this data is sufficient or not. And then for the data preparation, we have to classify the data into different chunks. Which data parts can be used and which cannot be used for the training purpose or for the validation or testing purpose. And then very important, during the development of the learning model or the algorithms, you have to take a balance between the accuracy, interpretability, and transparency. This trade-offs regarding the development of the model is very important. There also the human involvement is essential. Finally, when you are evaluating the data through the specific defined model and you are getting some output, then you need to check, is the model, the solution is sufficient or it is perfect, accurate in terms of obtaining the project goals. So this is how the things happen in a AI cycle. Let me go with let me go with the models first. Then you will be understanding about the application. This is a normal supervised machine learning without any XAI. You all know we are extracting different features and then we are giving the data to the model as an input. Here you can take apple and cake, different colors of apple, different shapes of apple, different colors of cake, different colors of shape of the cake and smell we have given as a training data set. Now I want to check what is the product I'm having. Is it a cake or is it a apple? New instance I have given. Now from the available data set, the model which is trained, it has to diagnose, it has to predict and tell whether the instant newly added instance uh, is a cake or an apple. So using the multi machine learning or the deep learning algorithms, the model will be giving the output that it is cake. This is how the AI works. This is a black box approach. In white box approach, what happens is, here we are coming up with XAI model, not a normal multi machine learning model, but we are coming up with a new model, explaining model decision. Okay, how it will explain? It will first explain the data to the user, through which data it has been trained. Then it will give the justification to the user about the model. What are the different facts of the model, how it performs, how it gives the output, technically how the flowchart works, and what are the limitations and assumptions taken in the learning model. So these things will be given to the user to understand how the things are happening inside the box. That is called as the white box model, or the new type of explainable AI. What is the necessity of this? As I already mentioned, from black box to white box, reclaiming the human power in AI. Without interference of human, we are taking many decisions just depending upon the machines. So this XAI will involve the human interface in the machine process of AI cycle, through which the human power will be reclaimed. This is one of the important thing. We need the AI which is auditable, which is having transparency, which is also justifiable in nature. It should not be something which is very hidden in nature. Okay, so the decision making process should be very transparent in nature, and every human or the user should understand what the model is doing inside the box. So here what happens is, the bias whatever we are using, this bias will be reduced now. Because of bias, what happens? Many decisions will be distracted or deviated from their accuracy, right? Um, Bias means, you know very well. Okay, in the next coming slides, I will explain about the bias. In a normal human language, you can understand what is bias. That bias is the reservation, or the pre-programmed or preoccupied mindset through which the accuracy or the decision making process may get disturbed. So neutrally, a human should take a decision without having any bias. So with respect to that, this explainable AI plays a vital role in making the model user friendly, and also having a proper justification for the user to understand what's happening inside. The second important necessity why this XAI comes into picture is the legal issue. Rights to explanation. We are having data protection regulation, general data protection regulation. Okay, with this regulation is a legal regulation, is describing about the data, sort of data and data protection. Okay, so the limits to decision making based solely on the automated processing and profiling. This right has been avoided in the previous models. So a meaningful information and the logic involved in the decision should be informed to the user. This is his right. So legally, in the legal domain of the data protection also, This right is very important, which has to be executed or implemented through this XAI model. Example I have shown here, you can see the transportation, security, medicine, finance, military. Uh, this All these data are very sensitive data, very what we call secure data, where the protection or the security for this data is very essential. So we are entering into a new age of AI application. Machine learning models are opaque, non-intuitive, and difficult for people to understand. Now we are going into a user-friendly models, which will be understandable to the user, where their rights will be protected, and the transparency, trust, and the explainability will be crystal clear. These are the different examples, especially in the autonomous vehicles, in the forecasting of the power, or the scheduling of the optimum charging in the wireless charging stations. Okay, in the wind turbines, to get the optimum output from the wind. These are different domains. A huge amount of domains are there, where AI is not giving appropriate or a very precise output, because of which XAI is coming into picture. These are the things you can see here. The second model I have shown here, the graph, the learning performance and the explainability. If these two are considering as the major factors or the parameters upon which you want to develop the models, then those learning models will be completely different from the models available nowadays. Two types of models are there: directly explainable model, and the second one is post hoc explainability. In direct models, we are having linear model, decision tree, rule-based model. In your previous sessions, I think you have clearly gone through all these models. In the post hoc explainability model, deep learning neural networks, especially convolution neural networks and reinforced neural networks, are coming into picture, and then Ansible models also coming into picture. As I said, explaining the model with a global perspective or a local perspective, and then counterfactual introspection and inspection or the evaluation. These are the very important aspects when you are coming up with post hoc explainability. I will use a fictional use case and show the fictional explanation. Focus on the methods, not algorithm details. Provide references in the end. This is a use case. Loan application approval. Simple example, you can see a customer is there, Jason. His assets score is 88. Number of satisfactory trades is 0. And since account open, the transactions and number of inquiries and debt percentage, this is the input data given to the model. And the output, what we are asking the model is, what is the probability of getting the loan approval? So risk of failing to repay is more or less that will be considered by the banking sector as a data scientist, and as an approval it will be considered by the user. So three important things are there, three important entities or human involvement is there here. One is data scientist, one is loan provider, and the third one is customer who wants the loan. So data scientist must ensure the model it works appropriately before the deployment. This is a responsibility of the data scientist while you are giving your application or software or your learning model to the banking sector, because again, banking sector is also a very sensitive domain. It is very sensitive application where data protection and cyber security plays a major role, and also the prediction models whatever you are using, these models also should give appropriate justification for the loan officer and also for the bank customer. Okay, so data scientists should check, validate before the deployment of the model in the banking sector. There, the data scientist or the human involvement is there. Next one is loan officer. Loan officer need to check whether this customer is having the ability to repay the loan or not. What is his history? You have to check, need to assess the model's prediction and make the final judgment whether to give the approval or not. So loan officer should have a specific amount of understanding of the logic, how the model is giving the prediction. Then the loan officer will get a specific trust over the model, and it will be helpful for the loan officer to take the decisions. Similarly, bank customer also wants to understand why my loan has been not approved. What is the result? Whatever may be the result, it is approved or not approved. Why it happened, or what is the process they have followed? What is that flow of data happened in the model? That should be explainable in nature for the bank customer. So in the global perspective, these are the three important features: feature importance, rule approximation, decision tree approximation. These are the three types of models we are having. First of global explanation, this is the simple model. Training data set will be there, and high performing complex deep learning model will be there, and the information will be transferred in a closed loop control, and weight adjustment will be happening continuously, uh, and then this output or the decision will be interfaced to the uh, user at the end of this model. So same example I have continued here for the loan approval. Let us take a decision tree. Already you know about the decision tree. Asset score is less than 80 or more than 80. If it is less than 80, then we have to go with satisfactory trades. If it is less than or equal to 5, then you have to come up with asset score. If it is greater than 70, then we can go with loan approval. Next, on the other side, we can also check if asset score is greater than 80, how many months happen after the account opening, and then number of inquiries or the transactions happened in the account. So the logic, whatever is there, that should be prepared by the data scientist, and it should be given to the loan officer. So loan officer always bother about the risk. What is the percentage of risk? How much risk is possible for me? If the data of the customer is telling that he is unable to repay his previous loans in different timings, then it is a high risk application that should be rejected without any approval. If it is low risk, then that rules whatever the model is defining, that rules, and with respect to those rules, whatever the output we are coming, that should be justifiable and explainable in nature for the loan officer to take the risk of loan approval. Similar loan feature contribution, local rules are prototypical examples. The last example, explaining a prediction, local feature contribution. Customer is there. Why is Jason predicted of low risk? Can I trust this prediction or not? So these are the different examples. Slime is one of the model, LIME. In a similar way, different other models also available. Sorry. Yeah, I will skip all these. These are just examples. Yeah. Directly explainable model and post hoc explainability. What is the difference? As I said, directly explainable model will not have much trust and transparency, because you are not evaluating or auditing the logic behind the decisions. Sometimes it will take more human effort also to train, and sometimes impossible to train also. um, because it not work well always, because your model is not so precise enough. And post hoc explainability can be applied for any model where the trust will be there, and then faith will be there. But approximation techniques which are coming into picture, they have to be considered before going to take the risk. So here one reference also I have quoted here: stop explaining the black box machine learning models for high stake decisions and use the white box models. This is one of the important article. You can go through this article, which will be clearly explaining about the necessity and the significance of white box models. XAI evaluation happens with respect to these metrics or the parameters: inherent metrics, faithfulness, stability, compactness, user dependent measures, comprehensibility, explanation satisfaction, task oriented measures, impact on AI interaction, task or AI system satisfaction, and task performance are the behavior. These are the different toolkits you can use, available online. With the help of this, many GitHubs also coming up with explainable AI. Okay, you can use those different platforms, the tools also for your XAI. Yes, and this is what I was telling continuously. Competence, fairness, safety, usability, human collaboration, accountability are the transparency, privacy of the data, or the security of the data. These are the very important, crucial features which were unaddressed previously. So now, using these explainable AI models, all these are going to be addressed very precisely and clearly. Yeah, this is what I said about the bias. What is this unwanted bias? Discrimination becomes objectionable when it places certain unprivileged groups at a systematic disadvantage. Though it is unethical or illegal practice, but still, bias or the reservation is making the models unproductive or inaccurate. So here you can see that the person who is well perfect physically and doesn't have any specific medical problems, he is sitting on a wheelchair, whereas the pregnant lady is there, old person is there, or women are there standing in the queue, who are having different variety of reasons to sit in the wheelchair. So this bias is there. No, this bias will make the decisions wrong. So while we are defining the model or we are defining the bias in any a deep learning model or your machine learning model, these should be reduced, this bias should be reduced, then only XAI will work very perfectly. In the previous case, in the black box model, we don't know what sort of bias have been used inside the model. Just you used to get the output or the result. But now, because explainable AI is coming into picture, bias also comes into picture, where it has to be reduced or minimized in such a way that the decision should become very perfect, and also the user should understand what sort of bias is used or how much amount of percentage of success depends upon the bias. Yes, this is about the fairness. You can see here the papers in terms of fairness. The huge amount of huge amount of research is going on in coming up with the new models, the which will be developing the trust for the user to use the model. So trust and accountability or auditability, interpretability, these are the features upon which the research is going on. And because of these features are principles, AI is becoming very popular as XAI, and coming up with different models are the applications. How to design, what are the different design challenges and some solutions. Later you can go with that. XEI toolbox are there. User UX means user defined model, user design, user centric design, or user understandable design. So your XAI algorithm should be in such a way that it should be explainable in nature. How to select and how to translate all this. One fits for all. It is a normal thing what we used to adopt in previous cases. But now in explainable AI, case to case, the model will differ. Only a single model will not fit for all problems. Okay, this should be the one of the major concern we have to take consider. Many user groups, domains, social context we have to consider while you are going to give the data and train the model. Yes, whenever you speak about user centric design process, you have to consider the confusions or the clarifications or the questions coming in the mind of user who is using the model. Those questions should be prepared, and thoroughly we need to identify what are the different needs of the user are there. Okay, unless you don't know the needs of the user, the design whatever you are going to give to the model, that will not give the accurate result. Simple example I have to quote here is, in one of my courses, I asked the students to go for a social what we call ethnographic survey and understand the problems of the public. They went there and they came up with the problem that for this village they don't have any what we call street lights. So they prepared one solution and they have given to the solution to the village. Then after we came to understand that those village people used to sleep by 6 p.m., because of which they never got a requirement of street lights. So without understanding the user mindset or the requirements or the needs, if you are designing the model, that model will not give a good output or the result. Okay, I will stop these examples and I will go directly into the renewable energy. I think everybody understood what is the major difference between a normal AI and an explainable AI. That is the major topic of focus given to me today to explain about what is explainable AI, which is coming into the market and coming up with different projections in terms of solar and also wind and also hybrid models. Let me start with this. XAI model. We are having three types: supervised, unsupervised, and reinforcement based learning. We are using deep learning algorithms for the classification of images and the pictures. And also, we are using convolution neural networks using the backpropagation techniques where the conversion of the data will be there. With the help of these models only, we are going to prepare the XAI model. But one important thing we will be considering here is explainable in nature rules will be approximated, and those will be displayed on the user dashboard through some user and machine interface. Through this interface, the explainability will be happen. Yeah, coming to renewable energy sources, as we all know that solar energy, wind energy are occupying a major portion of the energy production in terms of green energy. Already you will be aware about all those things. The challenges what we are facing in the renewable energy sector is intermittency, geographical limitations, and energy storage. As I already mentioned, solar and wind both are variable in nature, causing the supply demand mismatches because it all depends upon the nature, the irradiance of the sun, and also the velocity of the wind. So it is because of these uncertainties and the variations in terms of the inputs given to the model, the output may not come up with a precise or the accurate prediction or the forecasting of the system. So this is intermittency is one of the challenge which has to be addressed through AI or XAI. Second one is about the geographical limitations. As you all know that renewable energy is location dependent. The regions where huge amount of temperature will be there, sunny areas will be there, or the coastal belt where the windy regions are there. So site specific planning is required, and also the infrastructure development in terms of less resources, more outcome. So such sort of forecasting and prediction should be done through AI and XAI. The last one is storing the energy efficiently for the later use, because we know that solar and wind directly whatever the energy we are producing, we are using them, we are not storing. So for additional storage purpose, you need an extra what we call infrastructural requirement. So this storing energy efficiently for the later use remains costly, and technologically also it is very complex in nature. So for that solution also, how this AI and XAI can address the challenge. It empowers the optimization, forecasting, automation of the key operations within the solar, wind, hydro, geothermal, and bioenergy. We will explore AI's application across these renewable energy sources, emphasizing how XAI is transforming the energy production, improving the efficiency, and tackling the industry challenges. Let us start with solar energy. XAI uses the real-time environmental data, sunlight, temperature, tilt angle to dynamically adjust the orientation of solar panels to capture the maximum solar irradiance. Second is machine learning algorithms analyze the performance patterns and environmental factors to optimize the panel placement or the adjust angle throughout the day for getting the maximum power through the panels. Sun power utilizes AI-based tracking system that allows the panel to move based on the sun position, improving the efficiency up to 55%. So this optimization are the forecasting of the sun data coming from the sun, all can be used with the help of this XAI. Because of this XAI, it increases the efficiency in this generation, and also it maximizes the output even in particularly cloudy or the low light conditions, and reduces the need for manual adjustment and improves the energy capture. Data tools gather the operational data from solar panels and related components to predict the faults and failures. And the second important thing is about the maintenance. Once you are generating the power, second comes about the maintenance. Partial shading effect will be there, or breaking of the solar panels may happen. Some external some external calamities also may affect the solar system. So to those faults and failures, the data analysis is very important. And through these XAI algorithms, we can predict when the equipment are likely to fail, when the model is going to address the fault, a specific fault. So this XAI will be coming up with the different emerging models. Solar Edge is a tool which uses the AI to monitor the solar inverters and identify the potential failures before they cause the system downtime. Benefits: minimize the downtime, improves the system reliability, and reduces the maintenance cost. And then solar irradiance forecasting. On the other side, you are also having this satellite data, the weather data, solar irradiance. So we can predict the nature parameters like solar energy, from which time to which time, in which region specifically, in which site. With the previous history of the data, through which we can come up with different deep learning models, and we can come up with different XAI models. Google's DeepMind is also one of the tool. Google data centers also there. Increase the grid stability and better integration and dynamic energy pricing. This is about solar. Three sectors you can go with. Those who are interested to do the research in XAI. One is solar irradiance forecasting. One is predictive maintenance of the solar plant, and one is solar panel optimization, or the power maximum power tracking algorithms, or MPPT. Next comes the wind energy. XAI uses the weather data, including the wind direction, velocity, temperature, air pressure, to predict the wind speed and power generation potential. Machine learning models analyze this data to create the short-term and long-term wind term forecasting. Wind turbine operators like VSTARS is also one of the tool you can use to predict the wind patterns and forecast the energy production. It optimizes the energy generation, reduces the risk of turbine over exertion, and predictive capabilities. This is wind speed forecasting. Second one is wind farm optimization. It helps in the optimal placement of the wind turbine in a wind farm, where exactly it has to be placed. That is also very important. Accounting for the wind patterns and turbulence and geographical scenario. So XAI controls the turbine performance in real time, adjusting the turbine speed and angle based on fluctuating wind conditions. Okay, different tools are there like GE Renewable Energy. It is also one of the algorithm AI tool to optimize the placement and operation of wind turbines across the large wind farms. And then comes about the maintenance of turbines. We can use IoT sensors installed in the wind turbines, which will be sensing and giving the real-time data for the AI models to continuously monitor the status of the wind turbine. Why is there any vibration or noise is there, or any fault happens, the turbine misalignment is there, or blade damage happened, or rotor position, or the angle, gearbox failure. All these can be predicted with respect to the sensed data of the model, and through which we can develop the XAI model, and we can come up with the predictive maintenance algorithms. These algorithms will help in reducing the unscheduled downtime, maintenance cost, and extending the turbine lifespan, and also the reliability. Similar sort of applications also there in hydropower, water level prediction, where we can take the historical water data, weather patterns, and satellite data, and then using different algorithms, hydroelectric reservoirs, we can improve the water management and grid integration. Optimal operation of the dams are there. So these are the different models, XAI models, which we can use to convert to address the challenges, and come up with a solution for which this XAI will give the trustworthy user-centric model with proper justification and rules to understand. This converts not only the machine language to the user language, but also it will appropriately address the transparency and the accountability of the decisions taken by the black box model. This is about the XAI and its application in solar and wind. Yeah, you can go through the resources, whatever I have shown here. And recently, I have published one paper also in Energy Reports. You can see if anybody is interested about this deep learning XAI model for solar and wind combined hybrid system. I have developed a inverter, grid connected inverter. This grid connected inverter will be predicting the grid side and also load side fluctuations, and it will be enhancing the profile of voltage, current, and power, and mitigating the harmonics available at the grid side and the load side by using a deep learning neural network model. This XAI model I have designed, and that model I have very precisely explained in my paper also. Just opening the box, what I can say. I haven't given the black box model. I have taken the white box model. Every step of the learning algorithm, what I have used to control the operation of the grid connected inverter, that whole system, whole logical design with respect to the flowchart and also simulation model, I have opened the black box and I have made it a white box, where each and every step I have mentioned how to design a basic model we can understand with respect to the grid connected inverter if you are taking this renewable energies sector as your research area. One more important thing I want to make a note here is whenever we are speaking about renewable energy sources, there are a huge amount of opportunities or the scope to do the research. So, in every aspect of this renewable energy sector, there is a scope for XAI to come into picture. XAI, as I said, it's a white box model. Normally, any AI model will be trained depending upon three important parameters. One is learning rate, another one is activation function, activation model, and third one is with respect to your configuration of the network. How many hidden layers are there, or how many what we call neurons are there in each layer. So there are three varieties of learning happens, or training happens in both online learning and also offline learning, batch learning. So in these two learning strategies also, we are using these three parameters as the base to develop the model. Either you have to come up with the learning rate variation, or you have to come up with the activation function modeling, weighted approach, or and third one is you have to come up with the layer based approach, model sorry architectural configuration model. So depending upon these three parameters we are developing a model, learning rate and all those things. I have taken in my paper about with respect to these two parameters I have considered. One is the learning rate and also one is your what we call weighted based activation function based system, where I have taken simple bias without going into the high level, and then the model was well trained with respect to online data. It is not offline data, well trained with respect to online data, where the system will be developed in such a way that the adaptability feature I have made it more predominant, where with respect to the learning rate variation, the adaptability will change. So whatever the adaptability we want, with respect to that adaptability, I have changed the learning rate, and I have made the model so simple. It looks like a complex because I have opened the box. So obviously many complex things what used to be happen inside the black box, now it should be explainable in nature to the user. So when each and everything what happens inside the box, if you open, it seems or looks like to be very complex, but actually it is not complex. It is user friendly to understand and take the decisions. This is how the explainable AI is working very crucially in terms of in making the user take the decisions boldly, effectively, with precise and accurate results. This sort of trust, transparency, and accountability going to develop by these XAI models. As this explainable AI is new, so I thought of explaining more about explainable AI because it's just next version of AI we can see. So already we are well aware about AI. From the last 4 days you are continuously learning about AI models. So the same AI models you can use here also, but one more extra module you are going to incorporate in such a way that the justification of the decision making process should be displayed on the user dashboard. This is the difference between a normal AI and explainable AI. Okay, I will close here. Anil sir, anyone having any doubts for 5 minutes?
Thank you, sir.
Yeah, welcome, sir. Yes, you can close the session. I think nobody is having doubts.
Thank you. Thank you, sir. Thank you for accepting our request under your busy schedule. Uh, we got information about normal AI and explainable AI for RES, and what are the challenges faced by RES and XI in renewable energy sources like solar, wind, and other sources. So thank you for your valuable information, sir.
Okay, thank you very much. Shall I leave, sir?
Okay, sir. Mm. So good evening, all. Today 12th session, 3:30 p.m. to 5 p.m. Next 13th session, 5 p.m. to 6:30 p.m. And next to 6:30 to 7:30 p.m. online test and feedback session. So all the participants, please attend the online test and feedback session. And also 7:30 p.m. to 8 p.m. is a validatory session. So in that validatory session, feedback from participants is very very important. So the certificate is considered certificate is issued on basis of your online test and attendance also. So thank you, sir. Thank you for just within 5 minutes start 12th session. Wait for 5 minutes, sir.